Have you ever felt small? Perhaps standing on a cliff top, the wind rushing past you, the vast churning sea stretching out to a horizon that seems impossibly distant. Or looking up at a truly dark sky, one far from the glare of city lights, where the stars are not just scattered points, but a thick, shimmering river of light, a celestial dust that seems to hang just beyond your reach. In those moments, we feel a sense of scale, a feeling of our own place in the grand scheme of things. But what if I told you that this feeling, this sense of awe and smallness, is only scratching the surface? That the universe, in its breathtaking, silent majesty, is both infinitely larger and infinitely smaller than our minds can truly comprehend. We're about to embark on an extraordinary journey to the edges of existence and back as we explore the universe from quantum to cosmological scale. We'll be travellers on an impossible voyage, shrinking down to sizes so minuscule they defy description, and then expanding outwards through 61 orders of magnitude, one followed by 61 zeros, past stars and galaxies to the very edge of everything we know. This isn't just a journey through space, it's a voyage through the fundamental nature of reality. Each step will reveal how the universe organizes itself at every scale, from the quantum dance of particles that make up your thoughts to the cosmic web of galaxies stretching across billions of light years. And remarkably, at every level, we'll discover the same patterns repeating, structures within structures, all connected by the same physical laws. You'll witness how the microscopic world gives rise to the molecules that form your body, how those molecules organize into cells, and how those cells are part of a living planet orbiting a star, circling around a galaxy, amongst trillions of others. By journey's end, you'll understand your place in the cosmic hierarchy, not as an insignificant speck, but as a conscious observer made of elements forged in ancient stars. I'm Rhiannon Deamer, and you're listening to the Astrum Sleep Space podcast. Join with me today as we take the ultimate cosmic journey, travelling from the quantum realm to the edge of everything, discovering how each scale connects to create the magnificent universe we call home. Let us begin our journey by travelling inward, past the familiar sensations of the room around you, past the feeling of the air on your skin, past the very cells that make up your body. We are going smaller, smaller than a grain of sand, smaller than a microbe, smaller than the wavelength of light itself. We are heading for the quantum realm, the Planck scale, 10 to the minus 35 meters across. This is the smallest possible meaningful length in the universe. If you magnified a proton to the size of our observable universe, the Planck length would still be smaller than an atom. Here, space and time lose familiar meaning. Physicists still don't have the equipment to observe the universe at this scale, but we believe it may be bubbling with virtual particles that pop in and out of existence. A place where all four fundamental forces, gravity, the weak force, the strong force, and electromagnetism, merge into one. As we zoom out, we encounter fundamental particles. At 10 to the minus 18 meters are the smallest components of matter we know of, quarks. There are 6 types or flavors of quark, named Up, Down, Strange, Charm, Top and Bottom. Think of them not as tiny, hard spheres, but as shimmering points of energy constantly in motion. They cluster together in groups of 3. Imagine 3 tiny, energetic lights, 2 up quarks and 1 down quark. They are bound together by an invisible yet incredibly powerful force. This is the strong nuclear force carried by particles called gluons. The name is apt. They truly are a cosmic glue, binding these quarks together so tightly that nothing can pry them apart. This little trio of lights, this dance of energy, is a proton. Change the recipe to 1 up quark and 2 down quarks, and you have a neutron. These are the building blocks of atomic nuclei, the very core of matter. But they are not alone in this subatomic world. There is another family of particles, the leptons. The most famous lepton is one we are all familiar with in our daily lives, even if we don't realize it. It is the electron. Unlike the quarks, the electron is a solitary creature. It is fundamental, meaning we don't believe it is made of anything smaller. Picture it not as a tiny planet orbiting a star, but as a cloud of probability, a haze of potential. We can never know exactly where an electron is and how fast it's moving at the same time. This is Heisenberg's uncertainty principle, and it is a fundamental rule of this quantum world. The electron is negatively charged, while the proton is positively charged. And just as with magnets, opposites attract. This attraction is governed by another fundamental force, electromagnetism. It's carried by another particle, the photon. The photon is a particle of light, a carrier of energy. Every time you feel the warmth of the sun on your face, you are feeling the energy of countless photons that have travelled 150 million kilometers through space to reach you. So here we are, at the very foundation. A universe of quarks, leptons, and the forces that govern their interactions. The strong force binding the heart of atoms. The electromagnetic force holding atoms together. There are 2 others as well, the weak nuclear force, which governs radioactive decay and helps power the sun, and gravity, the gentle, persistent force that, as we shall see, shapes the entire cosmos. Now, let us begin to zoom out. Slowly, gently, we pull our perspective back from the quantum dance. We are now at 10 to the minus 15 meters. We see the protons and neutrons, once our entire universe, now clustering together. In the simplest atom, a single proton forms a nucleus, and around this nucleus, a cloud of probability, a single electron is held in place by the gentle pull of electromagnetism. This is hydrogen, the most common element in the universe. It is the raw fuel of stars, the stuff of nebulae, the starting point for everything else. As we continue to pull back, we see larger nuclei as protons and neutrons combine to build the other elements. 6 protons, 6 neutrons, and 6 electrons. You have carbon, the basis of life on Earth. 8 of each, and you have oxygen, the air we breathe. 26 protons, and you have iron, forged in the heart of a dying star. Look at the structure of these atoms. A tiny, incredibly dense nucleus, and then a vast, cavernous space where the electrons reside. If the nucleus of a hydrogen atom were the size of a pea in the centre of a football stadium, the electrons' cloud would fill the entire stadium. Atoms are mostly empty space. The chair you are sitting on, the ground beneath your feet, you yourself. You are almost entirely nothingness. The feeling of solidity is an illusion, a result of the electromagnetic forces between the electron clouds of your atoms and the atoms of the world around you repelling each other. You are not touching the surface you are resting on. You are levitating an infinitesimal distance above it, held aloft by a sea of invisible forces. Let's expand our view further. From the atom, we move to the molecule. We see these individual atoms now beginning to interact. An oxygen atom, with its 8 electrons, shares 2 of them with 2 hydrogen atoms. They form a bond as the 2 electron clouds change shape and connect the atoms together. This is a molecule of water, H2O, a simple, elegant arrangement that makes life possible. Carbon atoms link together in long chains, forming the complex backbones of organic molecules. They join with hydrogen, oxygen, nitrogen, and other elements to create the incredible complexity of life. Amino acids, proteins, DNA, a double helix of information, a code written in atoms containing the blueprint for a flower, a tree, a bird, you. We are now moving from the realm of the invisible to the familiar. Billions upon billions of these molecules, these tiny structures of bonded atoms, come together. We see grains of sand at around 10 to the minus 7 meters across. These are about the smallest individual things the human eye can see. We move out further to fibers of wood, crystals of ice, the intricate and delicate structure of a leaf. The scale continues to expand to a centimeter. We are now at a scale we can see, we can touch. We are leaving the abstract world of particles and forces and entering the world our senses let us experience ourselves every day. As we continue to pull back, even a single drop of dew becomes just one of many on a vast, intricate web. The web itself is made of silk, a protein spun by a spider, a creature built from trillions of cells, each a bustling metropolis of molecular machinery. The web is attached to a blade of grass, part of a vast green lawn. The lawn is part of a garden. The garden, part of a town. The town, part of a country. Now we are on scales of kilometers across. Our perspective is now rising, lifting us up into the air. We see the patchwork of fields and forests, the silver threads of rivers winding their way to the sea. We see cities glowing with a soft electric light as night begins to fall. We are looking at the surface of a planet, our planet, Earth. From this height, the world seems peaceful, quiet. We can see the grand patterns, the curve of a coastline sculpted by waves over the millennia, the jagged spine of a mountain range pushed up by the slow, inexorable collision of tectonic plates, the swirling, white patterns of clouds, vast systems of water vapour moving through the atmosphere, driven by the energy of a distant star. This atmosphere, this thin blue veil, is all that protects us from the harshness of space. It's a blanket of air, 78% nitrogen and 21% oxygen, plus water vapour and trace gases. All this gas is constantly moving and swirling around, creating clouds, winds, and huge storms that lash the surface of the Earth with rain, hail, and lightning. All this is held in place by the planet's gravity, that gentle, persistent force we met in the quantum realm. Here, on a planetary scale, it is a dominant power. It is the force that pulled the dust and gas together to form this planet 4.5 billion years ago. It's the force that holds our oceans in their basins and our feet on the ground. It is the silent, constant companion of our existence. We continue to rise. The curve of the Earth is now obvious, a beautiful blue arc against the blackness of space. We are in orbit. Below us, continents drift by in silence. We see the vast ochre expanse of the Sahara, the deep, verdant green of the Amazon rainforest, the brilliant white of the polar ice caps. At night, the planet transforms into a web of lights, a neural network of human activity, tracing coastlines and river valleys. As we move further still away, Earth starts to shrink. Its magnetic field, generated by molten iron core convection, creates an invisible shield, protecting its atmosphere and surface from harmful solar radiation. Without this protection, Earth might have become as barren as Mars, which lost most of its atmosphere billions of years ago. We are now a moon's distance away, looking back at a marble of blue, white, and green, suspended in the velvet darkness. It looks so calm, so serene. All of human history, every triumph and every tragedy, every symphony and every battle has played out on that tiny stage. Every living thing we know of is there, a thin film of life clinging to the surface of a rock, hurtling through space. Let us now expand our view further. Our beautiful Earth is not alone. It is part of a family. At the centre of this family is a star, our sun. It's a vast, churning ball of hot gas, mostly hydrogen and helium. In its core, the pressure and temperature are so immense that hydrogen atoms, the simplest element, are fused together to create helium. This process, nuclear fusion, releases an enormous amount of energy. The light and heat from this reaction travels across space, bathing our planet, driving our weather, and powering all life. At 1.4 times 10 to the 9 meters across, the Sun contains 99.8% of all the mass in our solar system. Its gravity is the anchor that holds everything in place, that pulls its own atoms together strongly enough to fuse their nuclei together, converting 4 million tons of matter into energy each second, producing the light and heat driving virtually all solar system processes. Closest to the Sun are the small, rocky planets. Mercury, a scorched, cratered world. Venus, shrouded in a thick, toxic atmosphere of carbon dioxide, its surface hot enough to melt lead. Then our Earth in the Goldilocks zone. Not too hot, not too cold, just right for liquid water and life. And Mars, the red planet, a cold, desert world with a thin atmosphere and the tallest volcano in the solar system. Beyond Mars lies the asteroid belt, a vast ring of rocks and metal, the leftover debris from the formation of the solar system. And beyond that, we come to the giants. Jupiter, a colossal ball of gas, larger than all the other planets combined. Its surface is a maelstrom of swirling clouds, with storms larger than our entire planet, like the Great Red Spot, a hurricane that has been raging for centuries. It has its own system of dozens of moons, some larger than the planet Mercury. Then comes Saturn, the jewel of the solar system, with its breathtaking system of rings. These rings are not solid, but are composed of billions of individual particles of ice and rock, each in its own orbit around the planet, a glittering celestial river. Further out still, we find the ice giants. Uranus, tilted on its side, rolling through space like a cosmic barrel. And Neptune, a deep, mesmerizing blue, with the fastest winds in the solar system, whipping through its frozen atmosphere at over 2,000 kilometers per hour. And finally, beyond Neptune, lies the Kuiper Belt, a vast, icy frontier, home to dwarf planets like Pluto and countless comets, frozen relics from the dawn of the solar system. Our solar system is vast. The distances are immense. If the Earth were the size of a peppercorn, Jupiter would be over 300 meters away, and Pluto would be over 2 kilometers away. And the Sun, on this scale, would be a grapefruit. It is an enormous, mostly empty space, with these tiny islands of matter held in the gentle, unyielding grip of the Sun's gravity. Now we must take another great leap. We pull our perspective back to 10 to the 13 meters, so far that our entire solar system, our Sun and all its planets, shrinks. It shrinks until the Sun is just another point of light. It is indistinguishable from the other stars around it. We are now in interstellar space, the space between the stars. We zoom past our nearest star, Proxima Centauri, at 4.25 light-years, 4 times 10 to the 16 meters away from Earth, and into the void. What we see is staggering. Our Sun is just one of an estimated 200 to 400 billion stars in our home galaxy, the Milky Way. From this vantage point, our galaxy is a magnificent, swirling spiral. It has a bright, central bar made of older, yellow and red stars. From this bar, great spiral arms curve outwards like a celestial pinwheel. These arms are regions of active star formation. They are filled with vast clouds of gas and dust, called nebulae. These are the stellar nurseries. Inside these clouds, gravity is at work again. It pulls the gas and dust together into dense clumps. As these clumps grow, the pressure and temperature at their core increases until, once again, nuclear fusion ignites. A new star is born. It shines, pushing away the remaining gas and dust, and often a disk of leftover material forms around it. From this disk, new planets will be born. The same process that formed our solar system is happening right now in thousands of places throughout our galaxy. Our solar system is located in one of these spiral arms, the Orion Arm, about 26,000 light-years from the galactic center. We are in a relatively quiet part of the galaxy. It takes our Sun about 230 million years to complete one orbit of the galactic center. The last time we were in this position, dinosaurs were just beginning to walk the Earth. At the very centre of our galaxy, hidden from our view by clouds of dust, lies a supermassive black hole. It is called Sagittarius A star. It has a mass of about 4 million times that of our Sun. Its gravitational pull is what helps to anchor all the stars in the galaxy, keeping them in their long, graceful orbits. It is the silent, massive heart of our galactic home. Dark matter comprises 85% of galactic matter, forming vast halos around galaxies and extending perhaps 200,000 light-years from our centre. Though invisible, its gravitational influence shapes galaxy rotation and enables continued star formation over billions of years. The scale is now almost beyond numbers we can usefully comprehend. Our galaxy, the Milky Way, is about 100,000 light-years across. The sheer emptiness of it all is stunning. If you could fly from one side of the galaxy to the other at the speed of light, it would take you 100,000 years. And yet, our journey is not over. We must zoom out again. We pull back so far that our entire magnificent Milky Way galaxy, with its hundreds of billions of stars, its nebulae, its central black hole, shrinks to become a small, luminous smudge. And we see that it is not alone. As far as we can see, in every direction, there are other smudges of light. Some are spirals like our own. Some are elliptical, shaped like giant cosmic footballs, containing trillions of older stars. Some are irregular, chaotic collections of stars and gas. Each one of these smudges is a galaxy. Each one a city of billions or even trillions of stars. Each with its own planets, its own possibilities. The nearest major galaxy to us is Andromeda, another beautiful spiral, a little larger than our own. It is about 2.5 million light-years away. That means the light we see from it tonight left that galaxy 2.5 million years ago, long before modern humans existed on Earth. We are looking at it as it was in the distant past. When we look out into space, we are always looking back in time. Our Milky Way and Andromeda are the two largest members of a small group of about 50 galaxies, called the Local Group. Most of these are small dwarf galaxies, gravitationally bound to either the Milky Way or Andromeda. This whole group is about 10 million light-years across. But even this is not the end. We pull our focus out further still. Our local group becomes just a small clump. We see other clumps, other groups and clusters of galaxies. Some of these clusters contain thousands of galaxies, all bound together by their mutual gravity. Our local group is on the outskirts of a much larger structure, the Laniakea supercluster. This is a vast collection of galaxy groups and clusters, spanning about 500 million light-years. We are being pulled towards the centre of this supercluster, towards a massive galaxy cluster known as the Virgo cluster. As we continue to zoom out, we see that these superclusters are not randomly distributed. They form long, intricate filaments and vast, flattened walls, surrounding enormous, almost empty regions called voids. The universe, on this grandest of scales, has a structure. It looks like a cosmic web, a gigantic, three-dimensional network of galaxies. The filaments are the threads of the web, and the superclusters are the bright, dense nodes where the threads intersect. It is beautiful, ordered, and unimaginably vast. And everything we can see, every star, every galaxy, every supercluster, all the stuff made of the atoms we journeyed through earlier, makes up only about 5% of the total mass and energy of the universe. The other 95% is a mystery. About 27% is thought to be dark matter. We cannot see it. It does not emit or reflect any light, but we can detect its gravitational effects. It is the invisible scaffolding of the cosmic web, the extra gravity that holds the galaxies and clusters together, preventing them from flying apart. Without dark matter, galaxies as we know them would not exist. The remaining 68% is even more mysterious. It is called dark energy. It is a repulsive force, the opposite of gravity. It seems to be embedded in the fabric of space itself, and it is causing the expansion of the universe to accelerate. The vast voids in the cosmic web are getting larger, pushing the superclusters further and further apart. The ultimate fate of the universe may depend on the nature of this mysterious energy. We are now at the very edge of our journey. We are looking at the observable universe. This is a sphere with a diameter of about 92 billion light years. It is the portion of the universe from which light has had time to reach us since the Big Bang, the moment of creation some 13.8 billion years ago. We do not know what lies beyond this horizon. The universe may be infinite. There may be countless other observable universes far beyond our sight. Take a moment to rest here at the pinnacle of scale. Look at the cosmic web, this shimmering, delicate structure of light and gravity stretching across billions of light years, and remember where we began. We began in a seething, energetic sea of quarks and leptons. We saw them form protons and neutrons, which came together to form atomic nuclei. We saw electrons held in clouds of probability, turning these nuclei into atoms. We saw atoms bond together to create molecules, water, rock, life. We saw these molecules build our world, a beautiful blue planet, orbiting a star in the quiet suburbs of a spiral galaxy. We saw that galaxy as just one of hundreds of billions in a universe structured like a web, a universe that is mostly invisible and is expanding at an ever-increasing rate. Everything is connected. The strong nuclear force, which binds the tiniest quarks together, is what prevents atomic nuclei from flying apart, allowing for the existence of the elements that make up your body. The gravity that gently pulls you towards the Earth is the same force that binds galaxies into superclusters. The photons released by electrons changing energy levels inside an atom are the same photons that travel for billions of years across the cosmos for us to see a distant galaxy. You are not separate from the universe. You are a part of it. You are a way for the universe to know itself. The iron in your blood was forged in the heart of a dying star. The carbon in your DNA was created in a stellar furnace. The water in your cells is made of hydrogen, the first element, created in the Big Bang itself. You're a collection of stardust, a temporary arrangement of ancient atoms given the gift of consciousness. And in this moment of quiet contemplation, you have held the entire universe in your mind, from the smallest particle to the largest supercluster. You have travelled across it all. As you drift now on the edge of sleep, hold on to that feeling. The feeling of connection, of scale, of quiet wonder. The universe is not a loud, chaotic place, but one of profound, underlying order and beauty. You are an intricate part of this cosmic tapestry. You are both infinitesimal and vast. You contain universes within you.